talk about classes. And classes invoke this idea of object-oriented programming. I'm probably not the best person to talk about object-oriented programming, since I'm an antique and I started programming with computer cards long before this stuff was, I'm not sure if it was invented, but it certainly was in any kind of use. But you're stuck with me. And I'll take you through this, and maybe your advantage in the sense that I don't really care that much for objects, but I see why you use them. So what is an object? And why do we do this? Object-oriented programming is, you could call it the latest craze in computer science, but it's really got legs. It's been here for a long time, and it's going to stay. The idea of an object is that you do something that is a little weird, particularly to those of us who started with Fortran 4, or assembly language even. You combine programs and data together, and you put that stuff into a single unit. Why do this? Well, objects are really very useful when you want to think about reusing code. And there's a very logical reason for that. When you write, let's say, a fast Fourier transform routine, the first thing you're going to need is to think about what kind of input does this fast Fourier transform require? Is there anything that needs to be predefined before I can call it? And all that stuff shows up in one place. If you compare that to old-style Fortran code, where you call something and you pass it some stuff, but before you can call it, you have to predefine some stuff that shows up in common blocks and things like that, that kind of code gets very hard to reuse. So when you have complicated programs that require more than just simply passing a couple variables and getting some result out of it, you do need to think about the data you're going to use with it. So what you may not realize is that you've been working with Python objects from about moment one that we've looked at the language. Okay? When we created this list A, we created an object and it carried with it subroutines or methods that are predefined for an object of type list. Okay? Same thing for a string. A string is an object and it carries with it, for example, this method called upper, which gives you back the string as all uppercase letters. You may not have thought about this, but both lists and strings define what to do with the plus sign. Okay? You take two lists and you can add them together with plus, concatenate them. You can do the same thing with a string, and here's a case where we have taken our string, we've called capitalize, which just puts the first letter, makes the first letter a T. Here we add to it another string, period and a space, and so on, and we built up a larger string. What happens, by the way, if you try to add a list and a string? Any guesses? Come on, cowards. Somebody. Errors, right. Why do you get an error? Because logically it doesn't make any sense, but that's not why you get an error. The reason you get an error is because, as you'll see, there will be no defined mechanism to handle that in the language, because nobody anticipated that anybody in their right mind would want to do that. But you can do that if you choose with your own objects. Okay, so let's look at how one defines an object, a class. Okay, so the first thing we need to do is define it, and we do that with a new statement. Looks a lot like what we used to define a function, which begins DEF, but now we say class. Okay, we define the name of the class that we're going to or object that we're going to define, and we give here what we're going to base it on. And if we'll talk about what that means to base it on, but if you are, for right now, we'll just say that you'll always say paren object, close paren, and then you start defining it. The next thing you want to do is you want to put a little bit of documentation as to what goes on here. So that's you stick in a doc string, and then you define inside the class functions that will be part of the class. And you'll notice something that's a little unusual. All these references to self. Now we use self here by convention. It's not, you can put any variable you want, but the first variable, and you'll notice also that these functions are part of the class. They're indented. Okay, so we define a function called underscore underscore init underscore, and the first variable, self, will be defined as the object itself as we use it. And then anything else we're going to pass to it. And every function that is part of the class will have as its first variable something that will map to the name of the function, the self variable. Okay? So you'll almost always define this underscore init, and this will get called when you create the object. So let's look at how we use this. First thing we need to do, if we put this in a file, we need to import it, and then we define a copy of the object. Okay, so I call it by saying demo, then the name of the class, my class, and then this requires one parameter. This one we get automatically, but that one needs to be defined. And so this is going to define a variable for us that's associated with the object. So here's how we handle data that's associated with our object. Okay, so we've defined this object now. Okay, and I can call my routine from this object, and here I pass it a variable, and what it does when it gets that variable is it prints out self.var. Okay, so this might be a little bit weird, but self.var got defined over there. That's a different variable from what we passed it, so it prints out what we did when we initialized, not what we did when we pass it this variable here. That's just the way we wrote. That's just the way that it was written. Unlike other languages that you may have seen, particularly C++, variables and objects are available to you. So I take this object, and I can reference the variable inside it, and there it is right there, and I can change it. Is that the best way to do object-oriented programming? No, but it's available to you. And so I can change this, and now if I call this routine again, it would print out self.var equals 2. Okay, so this is a very simple class. It's not going to be obvious at all why you would want to use these things from here, from this example, but let's take a look further and see what we do. Yeah. Yep. What does the question mark do? Nothing. The question mark will, var over here gets set to question mark, and then if you look in this routine, it never references var. Okay, I intentionally did this to confuse you a little bit. Okay, self.var is different than var. Okay, so I've passed it an argument, and I've done absolutely nothing with that argument in this call to my routine. Okay, are you still confused? Okay. Well, I wanted you to think a little bit better. I wanted to get your attention. Yes. I don't have to. Self.var, when I just define it, it's there. So if, and because I always have to run init, I can count on var being defined. So one of the things you probably want to do is initialize everything you're going to use in the init routine, but there's no requirement of that. So if I didn't have this definition here and I did it some other way, this routine would fail if I hadn't yet gotten around to it, as well as my bottom two commands. But if I wanted to, let's say I didn't have an init here or it didn't do this, I could then still declare create my object here, and then I could say my object.var equals this, just like I do here, and then this code would work. My routine code would work. So Python does not require declarations. There's no, it's just against the religion.
One problem with it, though, is if you misspell bar in code sometimes.
Right, there's no,
Type VSI because SZXK. Now you have two variables and you don't realize.
right, yep.
There is one that's
Right. Now, there are things that will help you do that. Just to repeat, yeah, because you haven't had any declarations, there's no checking. And so it's easy. But but you can look and see what's defined in a class, and you'll find there a variable you didn't expect. Okay. So so why do we, yes, Art, please. Right. Demo class is demo class.py is this file that contains this. In this particular example. Okay, I've created a file demo class.py. It contains all these lines, and when I use import demo class, it just pulls those lines into my routine. They're part of they're not in my immediate namespace, which is why I have to refer to it by demo class there. Now, if instead I started Python, or I had a Python routine, and I just put these lines in to my Python routine at the top of the file, I would do exactly the same thing. I wouldn't need the import, and here I would not have the demo class dot, because it would be part of the current namespace. Okay. Now, why would you do this stuff? Well, the nice thing is, and if this may or may not matter, but for many uses, you want to define multiple copies of the same type of stuff, and you want to carry with it the programs. So just as with lists and with strings, we defined as many as we need, we might want to do that with our myClass objects. So here in this code, again, I pull in using the import demo class. Now I create my object 1, I create my object 2. They're initialized, in this case, my object 1 self.var, or my object 1.var contains 1, and here we see that. And in my object 2, I initialize it with 2, so self.var in that object contains 2. And I can access those variables, and they're separate things. So that's one advantage of using a class for something, is that you can make as many of these things as you need. You're not stuck with just one copy. And you don't have to reprogram it every time you need it. Okay? The other thing, and let's compare that with a module. So we can just stick code into a file like this, but then what happens? So if, okay, I have, this is a module. I put this in a file called demomod.py, and in this case I have the same thing as I had before, a class. When I do import demomod, in this case I do it as dm so I can type it quickly, I define a variable and I can reference it, and if I call my routine, I get the value of that variable. But I only get one of these. And where any part of the code where I import demo mod, I'm changing this one variable. Okay? And I don't have the ability to make extra copies of it. I just get one. Okay? While with the class, I go through an extra step. I have to actually create the object, but then I get as many of these objects as I want to create. So that's one of the big differences. And in different cases in your programming, each one of these styles, in my opinion, has its advantages. So I was talking earlier about differences between Python 2 and Python 3. This is one of the, when you define objects, when you define classes, this is one of the places where Python 2 differs from Python 3. In Python 2, you'll see this all the time. I'm defining a class. It's brand new. It doesn't depend on anything else. I just put empty brackets there. Okay, I can do the same thing in Python 3 by just leaving out these parentheses. However, if you switch these two things around, in one case, I think this syntax will not be allowed in Python 3. This syntax in Python 2 does something different. So, moral of the story, don't do either. If you want to do either of these things, stick in object, okay? Because this will do exactly the same thing in both Python 2 and Python 3. Okay? But I bring it up because if you're looking at other people's code, including my own, you'll see this sometimes. But in terms of your own code, just always stick object in. Then you don't have to worry about whether you're using Python 2 or Python 3. Okay, so we saw the dir command before. Now that we're creating our own objects, we can use that on our own objects. So here, again, we've imported this demo class routine. We define the object, and we ask for a directory of what's in the object. And look what we see. We see my routine. We see a bunch of stuff. We have no idea where it came from. We'll worry about some of that later. And we see var show up. Okay, so this tells us what stuff is in the class. We'll talk about what some of the stuff does, but we can look at a little bit of it. If we look at what __ class is, it tells us the name of the class. If we look at string, that's str, it defines an object. Here's the name of the module that things came from. So there's various stuff that Python has defined for us when we define our class. Okay, I'm going to take a little bit of a detour to show you how classes are going to be used, but I'm going to define something that's useful as something that is already predefined for us in some places, and we may want to define for ourselves, and that's called an iterator. Okay, now, if you want to work with a large amount of data, let's say you want to do, you're working at Google and you want to do some processing on every hit that's occurred in the last hour, you don't want to read them all into memory and then start working with them. You want to find the first one, do something on it, pull up the second one, do something on it, and probably by the time you've gotten to the end, there's a whole new set to work on. Okay. You may also want to just simply do some processing on selected memory, selected elements that you're going to get to and do different things. So you may not want to pull up and put in memory every item in something that you're going to process. So some examples of that are, if you're reading in a very large file, you don't want to process it by pulling in every line of the file into memory and then start, let's look at the first line, let's look at the second line, let's look at the third line. if you're doing some kind of computation on a large number of variables and your values and you're going to stop at some point, you don't want to pull them all in and then start computing on them necessarily, particularly if something is computationally expensive. So let's take a look. What you may not have realized is that when you, for example, use a for loop, Python, it looks like Python has computed a 10,000 element list with this range command, and then it's going to iterate over each one. But in truth, this range command gives to the for loop each value as we need it. So we've used an iterator here even though we didn't realize it. We can iterate over a file too. If we open a file and we iterate over it like this, every time we go to this for loop, it's going to pull up the next line out of the file. When we iterate over a dictionary, again, it goes key by key and gives us each key one key at a time. It's doing all those things with iterators rather than generating a full list of all the dictionary keys and then supplying that. If we want to do that, we can. We can say mydic.keys, close paren, and that will supply a list of keys, and then we will iterate over each one at a time. But we don't have to work that way. So let's take a look at how we would implement an iterator. Okay, in order to do that, we need two things. We need a element in our class called __iter, and we need a routine called next. The next does not necessarily need to be in the same class, but usually makes sense it will be. So when iter is called, it's called with no arguments, and it returns an object that contains the next function. If the next function is in our class, then it just returns the name of the class. The name of the object, really. Okay, so next is then called with no arguments, and it does one of two things. It gives us either the next value we're going to need in the sequence, or it says I'm out of things to return, and it raises an exception with stop iteration. So we'll see how this is done, but here's a reference to where to look for more information on iterators. So let's set up a very simple class that does that generates. We've seen range. Range generates a bunch of numbers. We're going to set up a range. We're going to set up something called square root range, and this generates a bunch of square roots for us. Okay. When we initialize it, we're going to give it a value, a stop value, and we'll print out calling init just so that we see that value, and we'll save that value that gets called with. So we'll save it as in the class as self.stop. When we call __iter, it'll print out that it's done that. It's going to set another variable, self.count, to be 0. And it will return the name of the object. And then finally we'll define next. Next doesn't get any arguments, just like iter doesn't. And it checks to see, is count greater than or equal to the place where we've told it to stop? If it does, it raises the stop iteration exception. Otherwise, it just returns the square root of our counter variable. And again, so we can see what's going on, it prints calling next, and then it iterates this, and then finally it returns the value we've calculated. Okay, so we can call this, and if we so we can set up a reference to. So this might look like we've generated 1,000 square root values, but it really hasn't. Okay, what it's done, what it's going to do when we call this, is it's going to now iterate over this list. And we could also just as simply have done it by saying for SQ in square root range. So we'll see that it doesn't. If it had calculated all 10,000 of our results, we wouldn't see what we're going to actually see when we run it. When we run this file here, first thing we see is that it calls the init. Then it's going to call the iter, and the first time so that sets up once. It only does this once, and then it calls next, and it starts calling this routine, and it's going to stop when the square root is greater than or equal to 3. So the first time it calls it, self.count is 0, square root of that is 0. Second time, self.count is 1, square root of that is 1. Third time, self.count is 2, so we get here the square root of 2. This goes on rather boringly until we get to the square root of 8, and then finally the square root of 9. At this point, we hit a break and we go out of the loop, so we don't calculate any more values. So the iterator has allowed us to do some work without generating all 1,000 square root values. It's only generated the ones that's needed. Okay, and I get that behavior almost automatically by just including the 2 hooks needed for an iterator in my class. Okay, so if we want to make our class look more and more like a regular Python object, there's some more stuff we might want to put in. If we define this underscore underscore len double underscore function, like right here, then we can ask for the length of the object. If we add getItem to our function, then we can actually index values. So here I've defined I've defined my iterator with up to 10,000 elements. It doesn't actually have any of those calculated. If I ask for the length of it, it tells me there are going to be 10,000 elements, and I can access an individual value. If I ask for the 16th value, it gives me back the square root, and it looks like it even is looking like an array, because if I ask for too many values, it says I'm out of range. But in truth, it's generating the values as I need them, and only if I need them. So this is how we can start putting functionality into a class. All right, so let me see. So I think this is probably a good point to stop for today. When we pick up, I'll talk about some of the other things that objects do for us, and then we'll look at why you might want to use an object versus why you might want to use a module in your code. But it's a good point to stop for some questions. Yes? Sure. This slide here? I need to put the... Oh, why did it stop at this code right here? Because I put it there. I told it to stop. I told if I didn't put the statement here, it would go until it reaches 10,000, or at least one before 10,000, and then it would stop. So so the only reason it stops early is because of that statement, that final statement, which tests to see if I've gotten to a point where I've told it to break. And conceivably, I might use this in something else. Now, this isn't a terribly useful function, but it's an example of it's meant to be an example of how an iterator gives you something that looks to all purposes like the result of what could be a very expensive calculation, but you only need to calculate what you need as you're doing it. And the advantages of using something like this iterator come in 2 places. One case where the value is expensive, so you don't want to calculate it if you don't need it. Or another example may be when you're working with a huge number of values and you don't want to pull them all into memory at the same time. Okay, more questions? Yes.
Are there any other best practices, I guess, for making the code portable between 2 and 3?
Between 2 and 3. Are there other best practices? Yeah, actually, if you go to the notes from some of the previous talks, at one point I have a link to, I think, about 3 or 4 web pages which go through every single difference between Python 2 and Python 3. In reality, there aren't a whole lot, but that's one of them. Yes?
One that you don't have up there,
Yes.
you could have,
Mm-hmm.
is put parentheses around the argument
Yes. That would be another example.
after like 2.5, I think, they enabled maybe 2.
Somewhere, yeah. I don't think it's 2.5. I believe it's in. I believe, yeah. This is this is an example of something. This code will run in Python 3 as written, but at some point the use of print without parentheses will die in Python.
And there's an option to the Python command
To make that die now,
your Python command to see if there's
right?
damage.
So in Python, the reason I don't use print with parentheses is because BCDA Python does not accept the parentheses because it's 2.5. 2.6 was when they started planning for 3. So if you do this with the BCDA Python with the parentheses, it will fail. So I'm not yet using the parentheses. However, I've checked, and at least in as of Python 3.2, they haven't pulled the plug on the old style. But this is an example of something that will be incompatible some point down in the future. And it's going to hurt. However, there is a routine which you can take. It's called 2 to 3, number 2, TO3. And if you use that routine on a Python file, it will go through and it will clear up most of the incompatibilities for you. I think, for example, it'll probably stick that object in for you, and it will certainly change all of your prints for you. So there's an awful lot of automatic stuff that can be done to fix your code. So that's a very long answer to a very quick question, and it's a very incomplete answer as well.